Today let us discuss an amazing chapter, that is arithmetic progression. To understand what is arithmetic progression, let us understand what is progression first. And to understand what is progression, we need to know what is sequences and series. So what is sequence? Sequence is nothing but set of numbers arranged in a specific pattern. It is not necessary that the pattern should be a mathematical pattern. Take an example of sequence of prime numbers. So here we have prime numbers as 2, 3, 5, 7, 11 and so on. Well, we have understood what is sequence. Let us understand what is series. Series is nothing but the summation of the elements in the sequences. Example 1 plus 2 plus 3 plus 4 and so on. Note that series is the summation of the sequence. Now that we have understood what is series and sequence, let us understand what is progression. Progression is nothing but the sequence of numbers arranged in a specific mathematical pattern. Example 2, 4, 6, 8, 10 and so on. We can see that here we are adding 2 to the every term to get the next term. Now that we have understood what is sequences, series and progression, let us understand what is arithmetic progression, or we call it as AP. Let us memorize the table of 2. Here we have 2 ones are 2, 2 twos are 4, 2 threes are 6, so on and so forth. If we write these numbers in sequence, we will get the sequences as 2, 4, 6, 8, 10 and so on. Here we can observe that every term except the first term can be obtained by adding 2 to the previous term. So this types of sequences are called as the arithmetic progressions. In the arithmetic progression, the difference between the consecutive terms is constant. Well, let us visualize this now. Take a pyramid of bricks here. On the base of pyramid, we have 5 bricks. Above that we have 4, above that 3, 2 and 1. As we move upwards, the number of bricks is decreasing by 1. And as we move downwards, the number of bricks is increasing by 1. So if we write this in sequences, we will get first sequence as 5, 4, 3, 2 and 1. And another sequence as 1, 2, 3, 4 and 5. So in both the sequences, we can see that the difference between the consecutive terms is 1. That means this is an arithmetic progression. Let us define arithmetic progressions formally. The definition of arithmetic progression says that the sequence of numbers in which every term can be obtained by adding a specific number to the previous term. Here we have some examples of sequence given on our screen. First example is the sequence of 3, 6, 9 and 12 and so on. Here we can see that the difference between the consecutive terms is 3. And we can also see that we cannot count the number of terms in the sequences. Therefore, we can say that it is an arithmetic progression, as well as we can say that it is an infinite arithmetic progression. Let us take the second example. Here we have 20, 16, 12, 8, 4 and 0. Here we can see that the difference between the consecutive terms is 4. We can obtain 16 by adding negative 4 to the first term, that is 20. And we can obtain 12 by adding negative 4 to 16, so on and so forth. And we can also observe that there are 6 terms in the sequences. So this kind of sequence is called as finite arithmetic progression. Well, that we have understood what is finite and infinite arithmetic progression, let us see some terms related to the arithmetic progression. Consider an AP. We have 5, 10, 15, 20 and so on. You can clearly see that it is a multiplication table of 5. So when we denote this AP, we can write first term as A1, second term as A2, third term as A3, so on and so forth. And we can denote the first term as A. And the difference between every consecutive term, that is A2 minus A1, A3 minus A2 or A4 minus A3, is called as the common difference. And in this case, we have common difference as 5. Now that we have understood what is common difference and first term, let us write these terms A1, A2, A3, A4 and A5 and so on in this way. We can write first term, that is A1, as A, second term A2 as first term plus common difference, that is A plus D, third term, that is A3, is equal to second term plus common difference, that is A2 plus D, that is equal to A plus D plus D, that is equal to A plus 2D. And fourth term as A4 is equal to third term plus D, that is A plus 2D plus D, that is A plus 3D. Similarly, we can write A5 as A4 plus D, that is A plus 3D plus D, that is A plus 4D, and so on and so forth. This is called the standard form of arithmetic progression. In this chapter, further we will discuss how we can find the nth term of the arithmetic progression, and also we will discuss how we can find the summation of terms of arithmetic progression.